Most B-29 Superfortresses in the Pacific should have been lost forever, long before the war reached its end. Crippled by damage, distance, and mechanical failure, they were beyond the reach of any airfield or factory America had. They survived because the United States broke a fundamental rule of warfare and built floating repair ships to rescue B-29 seconds where the Pacific was meant to destroy them. If you think wars are won by weapons alone, this story will change how you see World War II. By the time the B-29 Superfortress entered combat over the Pacific, it was already burdened by a quiet contradiction. On paper, it was the most advanced bomber ever built. In reality, it was a machine that should never have survived the war it was designed to win. The Superfortress was not simply another bomber scaled up. It was a flying system of systems, pressurized crew compartments, remote-controlled gun turrets, advanced bombing computers, high-altitude oxygen networks, and engines that pushed the limits of metallurgy. Every mission demanded perfection from hundreds of components working in unforgiving conditions. When it worked, the B-29 redefined strategic air power. When it failed catastrophically. In Europe, such complexity could be managed. Damaged aircraft could be flown back to England. Engines could be swapped, systems rebuilt, and specialists consulted within a continental network of factories and depots. The Pacific offered no such safety net. It was not just another theater of war. It was a logistical abyss. From the Marianas Islands, the B-29 seconds flew missions that stretched the limits of range, endurance, and reliability. Thousands of miles of open ocean separated the bombers from American factories. Spare parts traveled by ship, if they arrived at all. Specialized tools were scarce. Skilled technicians were scattered across islands that had been empty coral reefs only months earlier. Every sortie pushed aircraft and crews closer to a point of no return. The enemy did not need to shoot down every bomber. Distance alone could do the job. Mechanical failure became as dangerous as enemy fire. Engines overheated. Hydraulic systems leaked. Electrical failures cascaded through tightly integrated systems. A single damaged component could ground an aircraft indefinitely. In theory, these bombers were assets worth preserving. In practice, many of them became stranded liabilities, sitting on airfields with no clear path back to the sky. Each grounded B-29 represented more than a damaged airplane. It represented lost bombing capacity, lost pressure on Japanese industry, and lost momentum in a campaign that depended on numbers. Strategic bombing did not succeed through isolated brilliance. It required mass. It required consistency. It required aircraft returning from missions, being repaired, and flying again without interruption. The mathematics were brutal. If damaged bombers accumulated faster than they could be repaired, the campaign would collapse under its own weight. Not because of Japanese defenses, but because the system sustaining the aircraft could not keep pace with reality. This was the problem that conventional doctrine could not solve. The Army Air Forces had never faced a situation where their most important weapon system operated so far from its industrial base. They had built the bomber assuming access to factories, engineers, and supply chains. The Pacific stripped those assumptions away. What remained was a machine that demanded industrial support in a place where industry did not exist. Writing off damaged aircraft was the simplest solution. It was also unacceptable. The cost of each B-29 was enormous. The training invested in its crews was irreplaceable. Losing aircraft to preventable logistical failure was not merely wasteful. It was strategically dangerous. The Pacific was not killing the B-29 through combat alone. It was killing it through attrition, delay, and distance. At this point in the war, there were only two options: accept that the Superfortress would bleed away faster than it could be replaced, or fundamentally rethink how an air force sustained itself in hostile geography. One option, preserve doctrine. The other preserved the war effort. Choosing the second option meant abandoning an assumption as old as air power itself: that aircraft belonged to airfields and ships belonged to navies. It meant admitting that no airfield in the Pacific could provide what the B-29 required. And it meant recognizing that the only platforms capable of carrying factories, tools, specialists, and power generation across thousands of miles were ships. This was not an incremental adjustment. It was a conceptual rupture. To keep the B-29 alive, the United States would have to do something that blurred the boundaries between services, doctrine, and identity. It would have to move industrial capacity forward, not symbolically, but physically. It would have to build factories that floated. Only then could crippled bombers be rescued where the Pacific was designed to destroy them. The decision did not begin with confidence. It began with fear. By late 1943, the Army Air Forces understood something they could no longer ignore. The B-29 was not failing because it lacked firepower or range. It was failing because it demanded an industrial ecosystem that did not exist in the Pacific. Every mission deepened the gap between what the aircraft required and what the theater could provide. The usual solutions were exhausted. More spare parts could not solve the problem. Faster shipping routes could not solve the problem. Even expanding airfield facilities offered diminishing returns. The distances were too vast, the damage too severe, and the systems too complex. The Pacific did not bend to incremental fixes. At this point, doctrine became an obstacle. Air forces were built around airfields. Navies were built around ships. Factories belonged at home, far from the reach of enemy action. This separation was not just organizational, it was psychological. It defined how wars had been fought since the birth of air power. The B-29 made that separation obsolete. Planning staffs began to confront an uncomfortable truth. If the bombers could not return to factories, then factories would have to move forward. Not symbolically, not partially, entirely. This was where the idea crossed from adaptation into heresy. An Air Force building ships was not merely unconventional. It violated institutional identity. The Navy already operated repair vessels, but those ships were designed for naval equipment and relatively simple aircraft. The B-29 existed on a different scale. Its engines, pressurization systems, remote armament, and bombing computers required precision machining, specialized testing, and highly trained personnel. No existing naval repair ship could support it. The solution would not be borrowed. It would have to be created. What emerged was a concept that had no precedent. The Army Air Forces would take ordinary cargo ships and turn them into mobile industrial complexes, not workshops, not depots, factories, floating repair ships capable of restoring B-29 seconds from damage that conventional doctrine would have declared fatal. The foundation was pragmatic. Liberty ships were available in large numbers. They were simple, robust, and large enough to carry heavy equipment. But everything inside them would change. Cargo holds would be stripped down and rebuilt as machine shops. Electrical systems would be upgraded to power industrial loads. Ventilation would be redesigned to support continuous manufacturing in tropical heat. These ships would not operate on improvisation. They would be engineered with the same rigor as stateside factories. Precision lathes, milling machines, welding stations, plating shops, instrument laboratories. Equipment selected not for convenience, but for necessity. Every tool represented a capability that could not exist anywhere else in the Pacific. One system mattered more than all the rest. The B-29's greatest advantage was altitude, and altitude demanded oxygen. Pressurized cabins reduced risk, but crews still relied on massive quantities of high-pressure oxygen. Forward airfields could not produce it at the scale required. Without oxygen, the bomber was grounded regardless of how intact it appeared. So the repair ships carried complete oxygen generation plants, compressors, storage systems, and distribution networks, capable of producing thousands of cubic feet of oxygen daily. These were not auxiliary systems. They were mission-critical infrastructure. Manpower followed machinery. Hundreds of specialists were assigned to each ship. Machinists, welders, electricians, instrument technicians, engine mechanics. Many had worked in aircraft factories before the war. Their skills were not interchangeable. They were concentrated deliberately, creating islands of expertise that could solve problems no dispersed unit could handle. The ships themselves became ecosystems. Raw materials were stocked alongside spare parts. Technical manuals filled storage spaces where cargo once sat. Power generation ran constantly. Work never stopped. 3 shifts rotated through 24 hours, driven by the simple arithmetic of war. Every hour a bomber remained grounded was an hour it was not over Japan. Movement between ship and shore was another bottleneck. Boats were slow. Time was lost in transit. So the repair ships adopted something else that did not belong there. Helicopters. Small, limited, and unreliable by later standards, early rotary wing aircraft proved invaluable. They moved parts and personnel in minutes rather than hours. A critical component could be delivered directly to a flight line. A specialist could be rushed to an airfield without waiting for launches or tides. The helicopter became a weapon against delay. None of this was elegant, none of it was cheap, and none of it was guaranteed to work. The repair ships represented a gamble of extraordinary scale. If they failed, the resources invested would be lost and the bombing campaign crippled. If they succeeded, they would redefine how air power could be sustained across impossible distances. By late 1944, the ships sailed west. They anchored in lagoons near Saipan, Tinian, and Guam. From the outside, they looked like ordinary cargo vessels. Inside, they waited as fully assembled factories, ready to prove whether the idea was brilliance or desperation disguised as innovation. The theory was sound. The equipment was ready. The specialists were in place. Now the Pacific would decide whether factories that floated could save bombers that should have been lost. The repair ships did not need time to prove their value. The Pacific gave them none. As B-29 operations intensified in early 1945, damage accumulated faster than any planning model had predicted. Every mission over Japan pushed aircraft beyond safe margins. Engines overheated. Flak tore through wings and fuselages. Hydraulic systems failed mid-air. Electrical faults cascaded across tightly integrated systems. Many bombers returned barely intact. Others did not return at all. This was the moment the entire concept faced collapse. Under conventional logistics, aircraft in this condition would have been written off. Shipping them back to the United States was impossible. Forward airfields lacked the equipment to rebuild them. Spare parts were incomplete. Expertise was fragmented. In any previous war, attrition would have quietly destroyed the bomber force without a decisive battle ever being fought. Instead, something unprecedented happened. Damaged components began moving toward the lagoons. Wings were removed from grounded B-29 seconds and transported by landing craft. Engines were pulled and ferried across open water. Instrument panels riddled with shrapnel arrived in crates. Hydraulic systems, oxygen assemblies, electrical harnesses, parts that no field unit could repair, flowed steadily toward the repair ships. Inside the ships, the response was immediate. Machine shops came alive. Lathes cut replacement parts from raw aluminum stock. Milling machines shaped components that no longer existed in supply catalogs. Welders rebuilt structural elements with tolerances that matched factory specifications. Instrument technicians repaired bombing computers and navigation systems that had been considered too delicate for field work. The work was relentless. 3 shifts ran without pause. Day blurred into night under artificial light. The ships vibrated constantly from machinery operating at full capacity. Heat built inside the holds despite ventilation upgrades. Every delay meant another bomber grounded, another gap in the formation over Japan. One system ran continuously above all others. Oxygen production never stopped. High-altitude bombing required vast quantities of compressed oxygen, and the demand increased as sortie rates climbed. The repair ships generated and refilled oxygen bottles around the clock, enabling aircraft to fly missions that would otherwise have been canceled before engines even started. Without this capability, the air campaign would have slowed to a crawl regardless of how many bombers survived combat. The helicopters became essential. They moved parts directly from ship to runway. They delivered specialists to airfields, where a single repair stood between an aircraft and permanent grounding. They turned geography into a manageable variable. Time, once the enemy, became something that could be traded, shortened, and controlled. Then came the moment no one could plan for. After the massive incendiary raids on Tokyo, dozens of B-29 seconds returned with damage so severe that writing them off would have seemed reasonable. Some landed with hundreds of holes punched through wings and fuselage. Engines were destroyed. Control surfaces barely functioned. Structural members were compromised. This was the point at which theory either survived or collapsed. The repair ships absorbed the surge. Components moved in waves. Structural repairs that would have taken months elsewhere were completed in days. Engines were rebuilt to factory standards, far from any factory. Systems were restored, tested, and returned to service with speed that defied expectations. Aircraft declared operational losses returned to flight status and rejoined the bombing campaign. The effect was cumulative. Every repaired B-29 reduced attrition pressure. Every returned aircraft preserved bombing mass. Every shortened repair cycle increased sortie rates. The system did not merely prevent collapse. It accelerated the campaign. Japanese planners counted destroyed bombers. American planners counted how many could be rebuilt. The difference mattered. By mid-1945, the repair ships were no longer experimental solutions. They were indispensable infrastructure. The bombing campaign depended on them not as support units, but as core components of air power itself. Without floating repair ships, the B-29 would have become a victim of its own complexity. With them, it became sustainable. The Pacific had tested the idea brutally. Factories that floated had survived. Now the question was no longer whether the system worked, but how long it could sustain a war that was reaching its most destructive phase. By the spring of 1945, the question was no longer whether the floating repair ships worked. The question was whether they could survive success. As the air campaign expanded, the tempo of operations increased beyond anything originally planned. Bombers were no longer flying occasional deep strikes. They were flying relentlessly. Sortie rates climbed. Targets multiplied. The margin for error disappeared. Every mission generated damage. Every mission fed the system. Factories across Japan were burning. Rail yards, ports, and industrial districts were struck again and again. But each success carried a hidden cost. Aircraft returned with shredded control surfaces, fractured structural members, engines pushed past their limits, and systems degraded by continuous operation. The repair ships were no longer responding to isolated surges. They were operating under permanent overload. There was no pause button. The workshops filled completely. Storage spaces overflowed with components waiting their turn. Every available square foot was pressed into service. Crews adapted by necessity, reorganizing workflows, prioritizing repairs not by completeness but by urgency. The goal was no longer perfection. It was speed without failure. Precision under pressure. Structural repairs demanded calculations performed under exhaustion. Machinists measured loads and tolerances, knowing a single mistake could doom an aircraft and its crew. Welders joined metal that would later endure extreme stress at altitude. Instrument technicians rebuilt delicate systems, knowing that errors would only reveal themselves over enemy territory. This was factory work performed in a combat zone, under tropical heat, with no margin for mistakes. The human cost mounted quietly. Personnel aboard the repair ships worked schedules that would have been unthinkable in peacetime. 12-hour shifts were routine. 16-hour days were common when urgent repairs arrived in waves. Fatigue became constant. Concentration had to be enforced through discipline and routine rather than rest. The irony was impossible to ignore. Compared to infantry fighting ashore, life aboard the repair ships was comfortable. There were bunks instead of foxholes, fresh water from evaporators, hot meals, even ice cream machines on some vessels. This contrast created a complicated morale. The men knew they were safer than those on the front lines. They also knew their work was keeping those front lines supplied with air power. Guilt mixed with pride. Every repaired B-29 became proof that the effort mattered. Crews watched bombers take off from nearby airfields, climb into the sky, and disappear north toward Japan. They knew which aircraft had passed through their workshops. They knew which engines they had rebuilt, which wings they had repaired, which instruments they had calibrated. The connection between labor and outcome was immediate and undeniable. This clarity sustained them. The helicopters never stopped flying. They carried parts, specialists, and urgency. Time saved in transit multiplied across hundreds of missions. The helicopters were small and limited, but their impact was disproportionate. They transformed logistics from a bottleneck into a weapon. The system adapted as pressure increased. More repair ships were deployed. Smaller maintenance vessels were added to handle routine work, freeing the major ships to focus on complex repairs. Capacity expanded not through elegance, but through necessity. The network grew denser, more resilient, and more specialized. By mid-1945, the repair fleet had become an ecosystem of its own. Aircraft that would have been written off weeks earlier returned to service. Engines rebuilt at sea performed as reliably as factory-fresh units. Structural repairs held under repeated stress. Oxygen production sustained missions that depended on altitude for survival. The system absorbed punishment and continued operating. Attrition did not disappear, but it no longer dictated the pace of the war. Japanese intelligence observed the bombing campaign and made reasonable assumptions. They tracked losses. They estimated replacement rates. They assumed damaged aircraft were permanently removed from the fight. What they did not see were the lagoons. They did not see the factories. They did not see bombers being dismantled, rebuilt, and returned to service in a cycle that defied conventional expectations. This misunderstanding mattered. The enemy believed American production was limitless. In reality, American repair capability was just as decisive. The ability to rebuild what should have been lost created an illusion of endless supply. It was not an illusion of numbers, but of resilience. The repair ships had transformed loss into delay. As summer approached, the system reached its breaking point without breaking. Every available resource was committed. Every assumption about endurance was tested. The air campaign surged toward its climax, and the floating factories carried the weight of sustaining it. The B-29 was no longer surviving because it was powerful. It was surviving because an entire industrial system refused to let it die. And as the war moved toward its final phase, the question shifted once again. Not whether the repair ships could keep up, but whether the campaign they sustained would force an end before the system itself collapsed under the strain. By the summer of 1945, the air war over Japan had crossed a threshold. The B-29 campaign was no longer experimental, adaptive, or tentative. It was relentless. Bombers flew almost daily. Incendiary raids devastated cities. High-explosive attacks shattered industrial infrastructure. Mining missions strangled shipping lanes. The pressure never eased, and neither did the demand placed on the repair system that sustained it. In June alone, thousands of sorties were flown. Each mission produced wear, damage, and failure at a scale that would have overwhelmed any conventional maintenance structure. Engines failed under sustained stress. Airframes accumulated damage faster than peacetime engineering models could predict. Systems designed for limited operational cycles were pushed continuously without rest. The floating repair ships absorbed it all. They no longer reacted to damage, they anticipated it. Workflows evolved to prioritize components most likely to fail next. Parts were fabricated before requests arrived. Engines were rotated through rebuild cycles as a matter of routine. The system had matured into something closer to an organism than an organization, adapting continuously to the rhythm of war. One aircraft came to represent the moment clearly. A B-29 returned from a mission with catastrophic damage. Cannon fire had torn through its forward fuselage. Instruments were destroyed. Engines were shot out or barely functioning. Structural members were compromised. By any reasonable standard, the aircraft should have been scrapped. It was not. Its components were dismantled and sent to the repair ships. Wing sections were rebuilt piece by piece. Engines were torn down, inspected, repaired, and reassembled. Instrument systems were reconstructed with precision that would have challenged factory technicians under ideal conditions. Days turned into weeks of concentrated effort. Then the aircraft flew again. This was no longer exceptional. It was routine. What mattered was not the individual success, but the pattern it represented. Bombers that should have vanished from the campaign reappeared. Losses that should have reduced combat power were transformed into temporary absences. Attrition slowed. Momentum was preserved. The strategic consequences were immense. Sustained bombing pressure forced Japan into a defensive posture it could not escape. Industrial output collapsed under repeated strikes. Transportation networks failed. Cities burned. The pace of operations allowed no recovery window, no chance to regroup or adapt effectively. The bombing campaign was not decisive because it was sudden. It was decisive because it was continuous. Continuity required endurance. Endurance required repair. The atomic missions that followed were carried out by B-29 seconds operating within this same system. These aircraft did not exist in isolation from the logistical network that supported them. They were the final expressions of a campaign sustained by months of relentless maintenance, repair, and reconstruction. When Japan surrendered in August 1945, the repair ships did not celebrate victory in dramatic fashion. They slowed. The flow of damaged components tapered off. Workshops that had run without pause for months began operating on single shifts. Helicopters sat idle on deck platforms that had once been lifelines. The war had ended before the system collapsed. In the aftermath, the scale of what had been accomplished became clearer. The repair fleet had preserved aircraft worth billions in modern terms. It had sustained sortie rates that made strategic bombing possible. It had projected industrial capability into locations where none had existed. And it had done so quietly, without spectacle, far from the headlines that focused on bomb tonnage and destruction. The floating repair ships were not weapons in the conventional sense. They did not drop bombs. They did not fire guns. They did not appear in victory parades. Yet without them, the most powerful bomber of the war would have gradually disappeared from the sky. The B-29 ended the war not because it was invulnerable, but because it was never allowed to remain broken. As the Pacific campaign closed, the factories that floated faded back into obscurity. Many were stripped of their specialized equipment. Some returned to cargo service. Others were scrapped. The personnel dispersed back into civilian life, carrying with them skills forged under extreme pressure. But the principle they proved did not disappear. They had demonstrated that modern warfare is decided not only by what a nation can build, but by what it can keep alive. That victory belongs to the side capable of sustaining complexity under pressure, across distance, and over time. The question that remained was not whether this system mattered. It was how deeply it would shape the wars that followed. The floating repair ships disappeared from public memory almost as quickly as they had appeared. After the war, there were no parades for factories that floated, no monuments for machine shops anchored in lagoons. History preferred cleaner symbols: bombs, aircraft, commanders, moments that could be reduced to a single image or date. Logistics rarely fit that mold. Yet the implications of what had happened in the Pacific were impossible to ignore inside military planning rooms. The war had revealed a truth that could no longer be dismissed as theory. Sophisticated weapons were only as powerful as the systems that sustained them. Distance was not an obstacle if industrial capability could move with the fight. The repair ships had proven that assumption wrong. Before the B-29 campaign, forward repair meant improvisation, field-level fixes, limited capability. Anything severe was expected to flow backward toward rear areas and factories. The Pacific had inverted that logic. Instead of pulling damaged equipment away from the front, the United States pushed the factory toward it. This reversal changed everything. Post-war planners studied the repair fleet not as a curiosity, but as a model. The idea that maintenance could be mobile, concentrated, and forward deployed began to shape doctrine. The concept of depth in logistics was no longer measured only by supply lines, but by how far repair and regeneration could be projected. Aircraft grew more complex, not less. Jet engines replaced piston engines. Avionics became denser. tolerances tightened, failure became less forgiving. The lesson of the B-29 did not fade with the aircraft itself. It became more urgent with every generation that followed. The helicopter operations aboard the repair ships offered another quiet signal of what was coming. What began as an expedient solution to save time evolved into a recognition that vertical mobility could reshape logistics entirely. Moving parts and specialists through the air, rather than across water or terrain, collapsed distances that had previously constrained operations. Later wars would build entire doctrines around this idea, but none of that was obvious in 1945. At the end of the war, the repair ships simply stood down. Equipment was removed. Hulls were reassigned or scrapped. The industrial ecosystems that had sustained the air campaign were dismantled piece by piece. Their success made them invisible. They had done exactly what they were designed to do and then quietly vanished. The men who worked aboard them returned to civilian life. Machinists went back to factories. Instrument technicians applied their skills to emerging industries. Engineers carried with them an understanding forged under pressure. They had learned that precision could be maintained anywhere if the system supporting it was designed correctly. That insight did not stay confined to the military. It diffused outward. The post-war industrial boom absorbed these lessons without naming their origin. The idea that complex systems could be supported far from their point of manufacture became normal. Mobile infrastructure, modular production, forward maintenance, concepts tested under fire became assumptions in peacetime. The B-29 itself became a historical artifact. It is remembered as the bomber that carried the war to Japan's cities and delivered the final blows. That memory is not wrong, but it is incomplete. The aircraft's endurance was not a natural property. It was engineered, maintained, rebuilt, preserved through effort that remained largely unseen. The floating repair ships forced a redefinition of what strength meant in modern warfare. Strength was no longer just the ability to strike, it was the ability to recover. This shift mattered because future wars would not be shorter or simpler. They would be fought across greater distances, with systems more complex and failures more catastrophic. The lesson of the Pacific was clear to those who studied it closely. Victory would belong to the side that could sustain complexity under stress without collapse. That lesson did not end in 1945. It was only beginning to shape what came next. There is a reason most people have never heard of floating repair ships. They do not fit the mythology of war. Wars are remembered through moments of violence and decision. A bomb falling, a city burning, a surrender signed. These images are clean, dramatic, and easy to understand. They assign victory to a weapon, a commander, or a single act that appears to change everything at once. Factories anchored in lagoons do not create such moments. The repair ships never produced a single instant that could be framed as decisive on its own. They did not win a battle in a day or turn the tide in a week. Their impact was cumulative, invisible, and difficult to isolate. They worked in increments, measured in hours saved, aircraft returned, failures prevented. That made them historically inconvenient. Even during the war, their work was rarely highlighted. Reports focused on bomb tonnage and targets destroyed. Losses were counted in aircraft that did not return, not in aircraft that returned because someone rebuilt them overnight. The repair ships lived in the negative space of statistics, defined by what did not happen. Bombers that did not stay grounded, campaigns that did not stall, attrition that did not spiral out of control. This invisibility extended beyond the war. Post-war narratives gravitated toward technological breakthroughs and dramatic conclusions. The atomic bomb became a symbol of sudden, overwhelming power. Strategic bombing was framed as a matter of range, payload, and destruction. The infrastructure that made sustained bombing possible remained largely unexamined. Yet, if the repair ships had failed, those narratives would look very different. Without the ability to rescue crippled B-29 seconds in the Pacific, sortie rates would have dropped steadily. Aircraft losses would have accumulated faster than replacements could arrive. Pressure on Japanese industry would have eased, not because defenses improved, but because the system sustaining the bombers could not keep up. There is no alternate timeline where this failure announces itself loudly. It would have manifested quietly, as delays, reduced formations, and canceled missions. The campaign would not collapse in a single moment. It would erode. This is why the repair ships matter. They reveal a form of power that does not announce itself through spectacle. They demonstrate that dominance in modern war is often achieved not through dramatic superiority, but through the ability to absorb damage without losing momentum. The Pacific was not won because America built the most advanced bomber. It was won because America refused to accept that advanced systems were disposable once damaged. The choice to rebuild rather than replace, to repair rather than retreat, reflected a deeper belief about how power should be applied. Complexity was not avoided. It was supported. This belief ran counter to many assumptions of the time. Other nations accepted loss as inevitable. Equipment was expected to wear out, to be destroyed, to be replaced if possible. The repair ships represented a different philosophy, that nothing valuable should be abandoned simply because it was difficult to save. This philosophy extended beyond machinery. The effort invested in rebuilding aircraft mirrored the effort invested in recovering crews, rescuing wounded personnel, and sustaining morale. The system treated both people and equipment as assets worth extraordinary effort to preserve. That consistency mattered. The repair ships were expressions of that mindset at scale. They were not elegant solutions. They were expensive, complex, and logistically demanding. But they worked because they aligned with a broader strategic culture that prioritized endurance over display. In the end, this is why the story feels unfamiliar. It does not offer a single hero or a single moment of triumph. It offers a system, and systems rarely receive credit, even when they determine outcomes. Yet without floating repair ships, the B-29 would have been remembered differently. Not as the bomber that dominated the Pacific, but as a weapon whose complexity exceeded the ability to sustain it. That fate was avoided not by chance, but by design. The final lesson is uncomfortable in its simplicity. Wars are not only won by what a nation can build, they are won by what it refuses to give up on. And sometimes, the most decisive weapon is not the one that strikes the hardest, but the one that makes sure the strike can happen again tomorrow. When people talk about victory in the Pacific, they usually point to the sky. They point to the B-29 Superfortress crossing oceans, climbing higher than defenses, and striking cities that had once seemed unreachable. They point to payloads, range, and destructive power. They point to the moment the war ended and assume the outcome was inevitable. It was not. The B-29 was not unstoppable by nature. It was fragile in ways that rarely appear in photographs or headlines. Its engines failed, its systems broke, its structure suffered under constant stress. Left to conventional logistics, it would have slowly disappeared from the campaign, one damaged aircraft at a time. That did not happen. It did not happen because somewhere far from the targets, far from the headlines, and far from the front lines, factories were working in silence. Factories that floated, factories that existed only because someone accepted a truth that doctrine refused to acknowledge. Air power alone was not enough. The Pacific was designed to punish distance. It punished supply lines, repair cycles, and assumptions about what could be sustained. The floating repair ships did not defeat this geography by force. They defeated it by refusing to fight it on its own terms. They turned water into infrastructure, isolation into proximity, delay into continuity. This was not a story about innovation for its own sake. It was a story about belief. The belief that complexity was worth sustaining. The belief that damage did not mean defeat. The belief that abandoning a system because it was difficult to maintain was a failure of imagination, not necessity. That belief shaped the war more than any single weapon. Japan saw bombers overhead and assumed endless American production. What it did not see were bombers that should have been gone, rebuilt piece by piece, and returned to service. It did not see engines reborn at sea, wings reforged in lagoons, or systems resurrected far from any factory map. The illusion of infinite strength was created not by numbers, but by repair. In the end, the floating repair ships were never meant to be remembered. They were meant to function. They did exactly that. And when the war was over, they disappeared, leaving behind an outcome that seemed obvious only in hindsight. The B-29 ended the war because it stayed in the air. It stayed in the air because it was rescued when it should have been lost. And it was rescued because America chose to build something no one expected, factories that could follow the war wherever it went. This is why the most important victories are often the hardest to see. They do not explode. They do not announce themselves. They simply make failure impossible, one repair at a time. When people talk about victory in the Pacific, they usually point to the sky. They point to the B-29 Superfortress, crossing oceans, climbing higher than defenses, and striking cities that had once seemed unreachable. They point to payloads, range, and destructive power. They point to the moment the war ended and assume the outcome was inevitable. It was not. The B-29 was not unstoppable by nature. It was fragile in ways that rarely appear in photographs or headlines. Its engines failed. Its systems broke. Its structure suffered under constant stress. Left to conventional logistics, it would have slowly disappeared from the campaign, one damaged aircraft at a time. That did not happen. It did not happen because somewhere far from the targets, far from the headlines, and far from the front lines, factories were working in silence. Factories that floated, factories that existed only because someone accepted a truth that doctrine refused to acknowledge. Air power alone was not enough. The Pacific was designed to punish distance. It punished supply lines, repair cycles, and assumptions about what could be sustained. The floating repair ships did not defeat this geography by force. They defeated it by refusing to fight it on its own terms. They turned water into infrastructure, isolation into proximity, delay into continuity. This was not a story about innovation for its own sake. It was a story about belief. The belief that complexity was worth sustaining. The belief that damage did not mean defeat. The belief that abandoning a system because it was difficult to maintain was a failure of imagination, not necessity. That belief shaped the war more than any single weapon. Japan saw bombers overhead and assumed endless American production. What it did not see were bombers that should have been gone, rebuilt piece by piece, and returned to service. It did not see engines reborn at sea, wings reforged in lagoons, or systems resurrected far from any factory map. The illusion of infinite strength was created not by numbers, but by repair. In the end, the floating repair ships were never meant to be remembered. They were meant to function. They did exactly that. And when the war was over, they disappeared, leaving behind an outcome that seemed obvious only in hindsight. The B-29 ended the war because it stayed in the air. It stayed in the air because it was rescued when it should have been lost. And it was rescued because America chose to build something no one expected. Factories that could follow the war wherever it went. This is why the most important victories are often the hardest to see. They do not explode. They do not announce themselves. They simply make failure impossible, one repair at a time. If you value real history beyond the battlefield, subscribe for more stories that textbooks leave out.